Ladies and gentlemen, let's begin our notes that are directly relating to thermal energy, which is one of the 7 forms that we've talked about. Thermal energy is the ability for heat to move from one area into another. And as we talked about any conversions that have happened in our unit with energy, we've talked about friction creating heat and that allows energy to leave that area, and that there's no such thing as a perpetual motion machine because heat is always lost. Thermal energy is a big culprit of this. Thermal energy will travel to anywhere that does not have as much of itself, where there's less kinetic energy happening in those molecules. I'd like to show you the 3 different ways thermal energy can travel through heat transfer. Let's start with the 2 kettles that are in this picture. The hot kettle on the left, if I were to look at the hot kettle under a microscope and see those molecules, we would see all sorts of kinetic energy of those molecules either vibrating and shaking where they are set in their solid structure, or if we look in those liquid molecules that are in the water on the inside, we would see them moving rapidly all over the place because they have so much kinetic energy, which is not the case with the cold kettle that's on the right-hand side. If I were to look with a microscope at these molecules, I would not see very much energy moving around. You see, energy is the ability to do work, and if it's lacking that temperature, it doesn't have energy for those molecules to move quite as much as those hot molecules are. As we're going to see right now, the travel of heat always goes from areas that have more energy, the hot area, to the areas that have less energy, the cold areas. This is the case in all situations where temperatures are different even by 1 degree. So what I'm going to do is I'm going to switch over further into this video until right about here. Let's begin by talking about the very first type of heat transfer. Conduction is the first type of heat transfer. Conduction occurs, and let me hit play here. Conduction occurs when there is direct contact between 2 objects. When your hand picks up that hot kettle that was on the left-hand side, immediately your hand can feel that heat. Well, see, some of that heat energy is going to go into your hand because it does not have as much heat. And you feel that only because there is direct contact that is occurring. Now, what if you have this kettle and you just put your hand near it? Until you have direct contact, you can't truly understand just how hot it is. Yes, you can have an idea if you put your hand near. There might be another version of heat transfer going on in the air between, but right now you need direct contact in order to feel that energy. After this, let's look closely at the atoms that are inside a material. When we talk about direct contact, let's talk about the atoms that are part of a metal. Metal is a material that we want to place in direct contact on our stove. But metal atoms cannot move around. They are very much stuck in their patterns. As you can see, these blue circles are representing the atoms of the metal material. Now, as we take a look, when the atom in the lower left-hand corner, let's say that's the one that is touching the heat on the stove the closest, when it receives that heat, it will pass on energy to the other atoms that are near it. This is how metals are great conductors of heat and passing that on. So this atom right here receives the heat and passes it on to any atoms that are nearby. It actually could be any of these 3. And this atom that is in the middle is going to pass its energy further on to the next one that doesn't have as much. So what you see right here is that the bottom row of these atoms that are receiving energy from the stove, they are going to pass it one by one by one, and you would feel the pot continue to pass that heat energy up toward the top. Much like if you put a spoon into some soup. The spoon that's directly in the soup is going to heat up right away, but if you let it sit for a while, by the time you grab the end or that handle of the spoon, it's going to be hot because it passed that energy molecule for molecule. And when you grabbed it with direct contact, you are feeling that heat transfer into your hand because your hand had less heat energy. Metals are great conductors of this. Just by their nature, they can pass that heat on in those molecules because they are in such patterns that allow it. Other substances don't pass heat very well. Let's jump to convection. In this next picture, we have a flame of which if you put your hand above the flame, you can feel the heat that's rising up into your hand. If you were to put your hand over here, maybe not so much, or over here, not as much either. But if you put it directly above, you're going to notice that that heat, those molecules are going to rise up to it. Convection is the second version of heat transfer. There is no contact going on with convection, as you can see. If you've ever heard of the term fluid, fluid means gases and liquids because they can flow around because they have random motion. The molecules are not connected to one another, as we talked about in our matter unit that was in November. These molecules have kinetic energy, and that depends on the heat energy that has been given to it. Think about our lava lamp. We talked about the lava lamp so much this fall that as the light bulb heated up the materials that were in the lava lamp, we saw that as they received more heat energy, they became less dense and they started to rise. I'm going to jump forward to watching molecules that are on top of direct heat. These molecules are directly on a flame, which if you notice right here, this is direct contact. This is conduction, as you can see. But right here inside, the molecules that are in the bottom of this flask are the first ones to receive that heat. And instead of staying where they are, like in the metals, they are going to swirl around and move. But they're going to rise because they're less dense. They need more space, as what we have said in the past. They start dancing, and whenever anything dances, you need more space for yourselves. So they spread apart and they rise up because they are less dense. Now, all of a sudden, we have trading of space happening and things are rising up, whereas those that are cooler are falling to the bottom because they're more dense, just like the lava lamp that we've talked about in the past. This is an example of convection. And I know that even though we are looking at liquids and water, this actually happens with anything that is fluid, that is liquid or gases. Air. When we have heaters in our houses, we notice that even in the winter or even in the summer, the floors of the rooms that are in upper levels, they become the ones that are warmest because the air that is less dense with the heat rises to the top. Let's jump a little bit further ahead. The last one is radiation. We talked about, a little bit further. Okay, we talked about, or I've just mentioned that conduction allows molecules with more heat to rise upward. So when the sun is shining on us and gravity is pulling downward, how do we feel the sun's light and the sun's radiation on us? As we take a look at the drawing in this video, a person is sitting maybe even on the ground and feeling the sun's radiation, that if there were to be an umbrella or a shade right over, immediately they would lose that feeling of the heat. Radiation is heat that travels in any direction. It does not matter if it is dense or less dense. This is because it travels in waves. Radiation is heat transfer by waves. Now, the sun's waves can travel straight through and reach us. Have you ever noticed in this past week in the snowstorm, we saw some sun the very next day on Monday, and when the sun was shining on the snow that was in the sun's light was melting, but the shade that was moving away from the sun had snow that hadn't melted yet, even though it was still the same temperature everywhere around. It was receiving direct hits of radiation from the sun's light, and therefore it was warming up and melting all over our roadways. It's something that's kind of fun to pay attention to if we do get any more snow. I hope that's not the case. But this third example is radiation. Now, many things radiate. If you put your hand in the near a light bulb, you could probably feel its heat. When you put your hands in front of a fire, you can feel its heat, but if you put your hands behind your back, you can no longer feel that radiation that's happening.